Welcome to Catalyst, a program about people, ideas, issues, and conversations around them.
I'm Doug Webster, host of this episode of Catalyst. Our topic today is Manufacturing Renaissance. My guest is Robert Simoneau, Associate Professor of Management at Keene State College. Bob has almost 40 years of education and industry experience in manufacturing and engineering in product design and development. He served 2 years as a program officer with the National Science Foundation Advanced Technological Education under the Division of Undergraduate Education. Bob also has a manufacturing engineering instructor at Wentworth Institute of Technology in Boston, a vocational technical instructor at Minimant Regional Technical High School. He served as adjunct professor at the University of Massachusetts, has consulted for Ford Motor Company, Polaroid, Timken Aerospace, and Smith's Medical, to name a few. He was also a guest scientist in composite development with the U.S. Army. He is an advisor to multiple manufacturing and engineering projects. Welcome, Bob. Thanks for being on the show.
Thank you, Doug.
My first question, Bob, is why do we need a renaissance in manufacturing and manufacturing education?
Well, basically what you have to look at is there's sort of been a false logic over the years in terms of the service sector that somehow we could live and develop create economic development around the service sector. So that kind of logic has sort of come around full circle, and as people's real wages have started to deteriorate, people are less apt to go out to eat. Your retail sector suffers. People try to economize wherever they can. So what is really viable in terms of career is manufacturing and manufacturing careers, because they tend to traditionally offer much higher wages, which is very obviously really stimulates the economy. Mm-hmm. So we've really need to, and I think policymakers are beginning to really begin to fully assess where we are today. And when they think about economic development, I think people are really starting to revisit and reevaluate their position on manufacturing and what it has given us in the past and what it can do for us in the future.
Okay, well, what are the long-term prospects for manufacturing in the United States and particularly New England?
Well, I think the United States is still extremely competitive in many different industries, and particularly in New England. If you read some of the later reports that have been put out by the New England Council, it shows that, particularly in New England, where we have such great universities and we have great partnerships with industry, we have a very viable supply chain that really doesn't recognize state boundaries. People go to find the talent where they can find it. Core technologies. We tend to still be extremely strong in a lot of really core technologies, and we see this in the biomedical field, aerospace. We also see it in electronics and really advanced technology areas, laser optics and optical devices, and still even in machine tool areas, we still seem to be able to hold our own in those areas.
Mm-hmm. Now, I mentioned NSF projects. Mm-hmm. What is your role as an advisor?
Well, having been there for 2 years, just to be really clear about the National Science Foundation role, the whole role of the National Science Foundation is really to fund good ideas. They work at the behest of Congress, and where the Congress sees where there are issues, they develop solicitations, and then they go out for requests for proposals. So they're peer-reviewed, they're very competitive, and the role that I play is to try and help schools develop their expertise in certain areas. So for example, the virtual ideation platform that's being run out of Central Maine, They're very involved with virtual product design and development over the internet. Dr. Birch in Connecticut, through the Regional Center of Next Generation Manufacturing, is very strong in terms of recruitment and retention of underrepresented students in STEM-related fields, and in particular in manufacturing. And then Ken Patton and his team out in California is very, very involved with rapid prototyping, or what we tend to call additive manufacturing or digital manufacturing. And again, these are all very exciting developments in the area of education and as enabling technologies in and of themselves. So they really are doing, it's really kind of a, kind of worn statement, but they really are doing some very cutting edge work in applying these technologies into the curriculum and integrating them and getting them so they become more mainstream in education.
Now, we talked before the show here about tooling. Now, why is tooling important? And how does it impact our global competitiveness?
Well, tooling is at the heart of any manufacturing venture. If you think of an inverted pyramid with the point at the base, tooling is really the die sets, the fixtures, the core pieces that go into making, manufacturing processes, and those manufacturing processes make components. Those components go into making sub-assemblies, then full assemblies, and then some product. So as soon as you start to lose your footing and lose your focus in the tooling area, you're really beginning to compromise the overall supply chain, the overall manufacturing footprint. So maintaining a very strong position in tooling is absolutely essential. For example, Ireland jump-started the whole economy based on the fact that they were very willing to provide tooling if you would bring the subsequent production and assembly and manufacturing to their shores. And it works very, very well, not only as a tactical procedure, but as a long-term systemic procedure. So I really can't emphasize tooling enough. And all of those programs, be it vocational programs, be it community college or university programs, to support tooling. It's an area that tends to be very hidden from the public, so they don't tend to really understand that. So it's difficult to keep that focus on tooling.
So what would you say the status of tooling education is right now within?
Well, the status of tooling education, and let's be specific here so people understand what we're saying. We're really talking about the areas of machine tool, welding, sheet metal, those types of areas. Metrology, the understanding of measurement, precision measurement. These are all critical. The status is, for lack of a better term, it's been very much compromised because, again, people don't really understand the implications in terms of economic development. It's the rare instance when I talk to small to medium-sized manufacturers that say, if I had more talented people, I could literally expand my business. Now, in a time when the economy is just really starting to move forward, that's a pretty interesting dynamic. There's a real disconnect between the economic development on one hand and the need of these people on the other, and what the part that tooling plays. So I would hope that policymakers would begin again to reevaluate some of these areas and really start to look at them much harder and understand their role in overall economic development, particularly as the base of manufacturing.
Now, we also talked earlier before the show about additive manufacturing, and what role does it play in tooling? And what is additive manufacturing, first of all?
Well, additive manufacturing, it's called a number of different names. Very early on it was called rapid prototyping. Then it segued into additive manufacturing. Some people now refer to it as direct digital manufacturing. It's actually a very exciting area. Traditionally, people would make things by what we call a subtractive process. You mill, you turn on a lathe, and you actually remove material to make items. In this particular case, additive manufacturing is basically you start with a platform, and you basically have it's almost like a tube of toothpaste that literally extrudes out a profile, and then it builds the object layer by layer by layer, using many different materials. They use paper. Some of the older machines use paper. Now the most common ones are plastic. And then they actually have machines that actually build using metal electronic beam with metal, so they can actually build metal components. And it's a very good way to begin to assess and evaluate core ideas, so you can make models. It's used by many different folks, for everything from biomedical to animators to set designers to architects to mechanical designers, because it's much easier for people to visualize. Some people have a very difficult time visualizing things on a two-dimensional screen versus a three-dimensional object. So in terms of innovation and creativity, it's very helpful, but just in terms of its standing alone as a manufacturing process, it's starting to gain legs, and it's actually starting to come into its own.
Well, where do you see additive manufacturing going in the future in both manufacturing processes and tooling and in education?
Well, to me, it's interesting because additive manufacturing is actually very sexy. It's very clean, and it's very exciting for students to be able. I bring some of my management students over to the labs where we have a couple of rapid prototyping machines, and they're really, really amazed at the idea that students will say, well, gee, you know, somebody has an idea on a computer screen, and then now it becomes a real object. It almost gets into the Star Trek kind of realm for a lot of people. And so it's really exciting. It's going to be a very viable tool to help us recruit students into these programs. But getting more specifically to your question about tooling, it's a fairly rapid way to build very soft tooling. You can actually make, in fact, I have an example here. If I can hold it up for a second.
Yeah, go ahead.
Again, this is out of Rapid Tech. It's a very simple little plastic device. It was grown, it was not machined. You have a lower half and an upper half, and you have an impression. So what they do is they pour a liquid resin, simply pour a liquid resin into this, well, it's called a sprue, and then you can let it cure, and you can actually make a very small, short pilot run. This happens to be a insulative jacket that goes into a main housing for a medical device. So again, if you know, trying to overcome some of the expensive tooling, this is a very quick way to make what we call soft tooling, to make short run production. So again, from concept through tooling to a component is greatly shortened, and again, from a pedagogical side, it makes it very exciting. From the manufacturing side, it becomes much more economically viable, and unit costs go way down. So it's exciting on both worlds.
What else do you have there?
Well, again, we can show the evolution of different ideas. An exciting concept that's fairly generic is the idea of making iPod cases. All the students know what they are. So these are different models that students can build, and part of the VIP program is the idea that students will conceptualize the idea. Another school will build it. Other schools will evaluate the documentation and improve out a lot of the documentation. And then UMass Lowell, you know, like a school like UMass Lowell will do the engineering. So again, you can see the initial concept, then it can become a little bit more elaborate, different sizes and shapes, and these can be fabricated very quickly. So it creates a whole different dialogue, a whole different way of communicating concepts and ideas. And again, it makes it much more exciting for students. And then we can actually build tools. Again, this is not a tool that you would use, but when we start to talk to machine tool students, like say at Central Maine Community College, it's much easier for a student to visualize what he has to machine. Now again, we're going to make this out of, although it's a model, we'll make this using the subtractive process, traditional machine tools, to actually make this out of aluminum and create a soft tool. So all of the features there are the tool. The students, again, it's easier to communicate. We often get on Polycom discussions, so we can dialogue back and forth. So there's no misunderstanding about features, materials, surface finishes, and so forth. So we can take on far more complicated projects that are far more involved than you would tend to see in a fairly traditional curriculum.
Yeah. Now, this is being done mostly at the college level, community college level, technical college level. What about high schools?
There is again, the particular solicitation that we're talking about is really focused with community college leadership and faculty-driven initiatives and concepts. But the NSF is fairly, they try to be minimally prescriptive, so they do honor trying to get high school students and involved with these projects. So to answer your question, there's a lot of outreach efforts by the community college to work with their local high schools. And you have programs like Project Lead the Way that are very viable, that allow for very synergistic partnerships and relationships to evolve.
Right, right. And that reminds me of Gene Goodrow from Orange County Schools will be here in Burlington May 24 as part of the National Association for Workforce Improvement Conference. It's actually a STEM conference, which if you want to elaborate on that connection with Ken.
She's going to come out. Ken is part of being a national center. Rapid Tech is a National Science Foundation national center. They're charged with having to do outreach to the larger community to have people understand the full implications of excuse me, of additive manufacturing to the broader community.
And this is Ken Patton in Southern California.
Southern California and his team. And she's part of his team. So she'll be coming to help explain the benefits of additive manufacturing as part of a curriculum, as part of a way of rejuvenating curriculum and making your curriculum more exciting. And also they have a lot of experience across a lot of different industries. So she's going to also help people see the broad spectrum of how this technology is applied across many different areas and industries.
Right, and we'll have more information on that at the end of the show, linked to the website. So, see this. Now I mentioned STEM because the focus of that conference is STEM. What does STEM stand for, and why is it important?
STEM stands for science, technology, engineering, and mathematics, and this is an area where a lot of these educators struggle to maintain student interest, and of course we tend to read a lot about how we tend to struggle in international scoring. So it's an area that, as an educator, it's something you always struggle with, to maintain students' interest in those areas, to gain that interest. Because programs like ours rise and fall on student enrollment, so we have to do what we can to make things as engaging. And again, the idea of additive manufacturing makes a lot of STEM-related concepts a lot easier to evolve, because you can start to now have manipulatives that you can work with and show and demonstrate with students, again, across a whole myriad of concepts in physics or kinesthetics or any number of different areas. You can even grow models that represent mathematical equations. So you can get very sophisticated in what you can do with models and so forth.
Now, STEM, the science, technology, engineering, mathematics, we hear from time to time people adding an A to that for arts, and abbreviated STEAM. What's your take on that, and where do the arts fit in? I mean, aren't arts part of it anyway?
Well, that's a good point, Doug. This is extremely exciting. I think a lot of our educational system has been extremely siloed. I don't think you get too much argument about that. So the opportunity to work collaboratively with other educators, be in an art design, studio areas, is very exciting. So the A is really, the arts have always complemented by advances in technology, everything from watercolors to set design. Animators are fully engaged with a lot of these same technologies. So we hope, part of our hope is that we can build that bridge across these areas that were once siloed. And again, to give you a small example, if you want to design a new stage set, well, additive manufacturing is a very nice way to begin to in a 3D representation, begin to build sets and be able to manipulate them and then work through various iterations of an idea.
Yeah.
So that the technology is going to help us begin to dialogue across many, many different disciplines, and really to support each other and to help each other as we
That's great. That's
as we
great.
move forward.
Now, if we don't strengthen STEM education, what will be the results?
Well,
Is STEM and manufacturing education. What do you think?
Well, I think it's again, I think we're facing global issues that are very technically intense. Even let's for instance take global warming and all of the implications of the various types of pollution and so forth. A lot of these are science-based, and people need to understand of some fairly, I wouldn't say complex concepts as much as they're involved. If they're presented correctly, people can work their way through a lot of these concepts and have a very fundamental grasp of some fairly involved ideas. So without STEM, again, if we don't have strong STEM-related education, the scientific challenges that face us today are pretty formidable. You need an educated public. You need an educated public in the area of STEM, because these ideas do run across many different disciplines. And you take some of the latest ecological disasters, like the BP Horizon oil spill, you get into whole kinds of ecology issues. And a simple misconception is, well, we'll use a dispersant, well, the algae will consume the oil. But what people don't understand is you have to take a holistic view, and they need to understand that algae consumes oxygen, and by depleting oxygen levels in the ocean, you then end up with extremely large fish kills.
Yeah.
So it's everything is connected to everything else.
Everything, yes. Now you mentioned the silos in education. Now, what role does project or problem-based learning play in helping to break down those silos, or meld those silos together? Whatever you want to call it.
Well, again, that's an exciting development. Problem-based learning is generally the way it's done is it's an open-ended problem.
Yeah.
They tend to be multidisciplinary, so you have to build teams of students who come from various backgrounds with various disciplines, and they work together to solve problems. So again, as an educator, it's very exciting for STEM to get various disciplines of students working together at various levels too. As you had mentioned earlier, high school, getting high school students involved with community college students, with undergrad or even graduate students to begin to solve problems.
Yeah.
And this is where some of these NSF models are going, and it's very promising. It's really exciting.
Well, great. Now, I mentioned earlier today, in watching Jon Stewart for my news fix, a person by the name of Austin Goolsbee, who is the Chair Council of Economic Advisors, was on, and he was talking about what we need to do economically as a country, and his slogan is educate, innovate, and build. And what's your take on that? I mean,
well, I think despite a lot of things, I think we're doing very well in education and innovation. I think we're very highly. It's when you get to the build side that things get to be a little bit murky at times, and in certain areas. I can remember working as a consultant for one of the firms, and it was using core technologies that were developed here in the United States, and basically as soon as we finished developing the product, it was going to be made overseas. So I think we've got to close that loop. We have to, and again, going back to that build, tooling again is at the core of this.
Yeah.
And again, the National Science Foundation does a very good job about going after the latest technologies, the latest innovations in a myriad of different areas. But like my wrestling coach used to tell me all the time, you get hit with the basics. The way you get beat is with the basics, and the basics are in the machine tool areas and all the complementary areas. So we really need to educate, innovate, and build here. I mean, it's going to go global at some point anyway. It's a global economy, but but we really need to strengthen our hand in that area.
Now, as far as building here,
Mm-hmm.
what role does that play in innovation? If we don't manufacture here, what's the consequence?
Well, like you and I
In
have
innovation.
discussed, right, like you and I discussed many times, a lot of the learning curve is within the making process.
Yeah.
And as you go through these various iterations, as you refine your processes, as you move in a commonly used term is continuous improvement, you get better and better at what you do. And there's a huge amount of learning in that process. And again, that's where the excitement is, that's where the viability is, and also that's where companies become extremely strong in their respective fields, and that gives them the competitive advantage.
Now, what can you say about the solar panel manufacturing? China, some people say China has it, and we should just forget about it and go on to something new. What's your take on that?
Again, I have to be pretty honest here. I'm having come from somewhat of a sports background, I am competitive, and I like to compete. And I think it's unfortunate that we sort of paint with a very broad brush when we say some of these things. So, well, it's sort of like, it's a very disposable kind of mentality. Well, we'll move on to the next thing or the next greatest thing. And at some point, I think what we need to do is dig our heels in and start to compete. Mm-hmm. And part of that competition is Evergreen Solar was developed in Massachusetts. And I think all policymakers need to, again, revisit how we do things here and to not necessarily move towards, not with the idea of protectionism, but the idea of nurturing fledgling industries. And it's not like we haven't done it before. Simtech was an excellent example where we realized the microchip business was being challenged by very effectively by the Japanese. And I don't understand why we can't do the same thing with renewables, where we strengthen our hand and work together collectively to make ourselves competitive in those areas.
Okay. Well, great. Well, thank you so much, Bob. I appreciate you coming up here from southern New Hampshire, and that will do it for today. Thank you.
Thank you. Thank you for having me, Doug.